Thank you, Michael, for that introduction. And yes, today hi everyone. I'm going to be speaking to you today about how I made my first contribution to Apache Arrow. So I will tell you a little bit more about myself as well, just to add on to what Michael just said. I am a software engineer and a developer advocate that's based in Harare, Zimbabwe. But I am also, I also work remotely for a company called Voltron Data. It's a company that was started by Wes McKinney. If anyone knows Wes, he's the creator of Pandas. And it's a very cool company to work for. And we do a lot of work around Apache Arrow, actually, and different open source Python projects in the ecosystem. Like Michael mentioned, I am also the previous vice chair and a director of the Python Software Foundation. If you've never heard of the Python Software Foundation, the PSF is the nonprofit organization behind the Python programming language. And if you want to find more information about what the PSF does, you can just visit python.org and look for the PSF tab. The Python Software Foundation has been really instrumental in my journey, coming from Zimbabwe and working on Python and getting introduced to the community. And so I'd really encourage you to do that. And a final thing about me is that I also am the previous chair of PyCon Africa. So if you are interested in maybe coming to different parts of Africa to speak about Python, go ahead and follow PyCon Africa on Twitter. So I just want to mention as well that when, as I'm giving this talk, I'm going to be walking you through how I made my first contribution to Apache Arrow, which is an open source project. And when I was making this talk, I decided to create this, or when I made the blog post that ultimately led to this post, I was thinking of anyone that maybe is considering contributing to a very large open source project, and maybe you feel really intimidated about contributing and you don't know where to start. I know I felt that way when I was getting started in the open source community. So hopefully this talk is going to be a guide for you as you get started, and will give you the courage that you need to get started on your journey. So, how does this work? Oh, I have to switch it on. Before we dive into the rest of the talk or the details of how to contribute or how I contributed, I thought I would share some interesting facts about Apache Arrow and PyArrow, which is the Python implementation of Apache Arrow. And I'm wanting to share these statistics with you because I think whenever you're considering contributing to a Python project, an open source project in general, actually, it's really important to feel like the project you're contributing to is useful or feel excited about the code that you're going to be working on. You don't want to be working on something that later on you discover is terrible and is maybe ruining the world or something like that. So hopefully, as I share some of these facts, you'll also see why I'm excited about the Apache Arrow project and contributing to it. So I grabbed a few download statistics from PyPI of a number of different Python packages that I'm really excited about, that I enjoy using. You know, you probably will see NumPy there. Travis is here somewhere. NumPy is on that list. Pandas is there. Scikit-learn, if anyone uses Scikit-learn. And of course, TensorFlow is one of my favorite Python packages for me. And of course, PyArrow is also on that list. And as you can see from the screen, PyArrow has been downloaded almost 400 million times. And it's also really interesting to know that PyArrow has been downloaded more times than Dask, PySpark, TensorFlow, and PyTorch combined. So that's a lot of downloads, and it means that, you know, it shows that the project is really popular. Over time, PyArrow was actually, Apache Arrow in general was created in 2016. And over time, the project has really grown in popularity. And if you take a look on GitHub this past week, Apache Arrow actually crossed 10,000 stars on GitHub in terms of people liking the project. So I think you can probably agree with me in saying that this project is really popular and hopefully being useful to people in the Python community. So, what is Apache Arrow? Arrow is actually relatively new. Like I said, it was created in 2016, and it was created when a group of database developers and data frame library maintainers came together, and they decided that they wanted to work together to solve some problems that they were all coming up against when they were working with tabular data. And I think this is really unique and really awesome about the open source community, in terms of the fact that they didn't decide to go off into their own corners and try to solve these problems by themselves, but came together and created a shared solution. And the people that actually contributed to this project were not just Python programmers, these were C++ developers, R programmers, even Rust people were in the mix, which is amazing. And they all came together to try to create a shared solution to make working with tabular data much better. So Arrow is, as you may have guessed, the solution that these people came up with. And Arrow is fundamentally three things. The first thing is that it's a columnar format. The second thing is that it's a group of libraries. And then the third thing is that Arrow is an ecosystem. So for the sake of this talk and for the sake of time, I'm just going to look at the first aspect of Arrow in order to help you get a clearer picture of how it's useful when we're working with tabular data. So to illustrate this, I personally love penguins, and I found a data set on GitHub from the Palmer penguin data set that has lots of information about penguins. And I went ahead and I loaded that data into a pandas data frame, and the table that you can see on the screen is that data frame and that data that I got from the Palmer penguin data set. Now, if I wanted to go ahead and I wanted to find the flipper length, the average flipper length of penguins in this data set, and I thought, this is really useful information to have. If I wanted to find that, I would need to find the mean of that column, and I would just take that column, and hopefully it would be a simple operation to do. Now, traditionally, data has been stored in things like CSV files or JSON files in a row-by-row format. So this way of actually storing data in rows is not very efficient, because when you are carrying out operations on your data, like calculating the mean of that flipper length column, what happens is instead of just taking the one column, if you're using things like CSV files, for pandas to actually work on that data, you need to load in the data row by row. So you're actually loading in all of these extra, columns of data on the side there that are just taking up unnecessary space in memory and are really slowing down your workflow. So this might not affect many people, and usually when you're working with CSV files, maybe you haven't experienced pandas or other data frame libraries being slow, or maybe not even working at all. But the minute you start to scale up and use much larger data sets, you'll start to notice how inefficient this is, like storing your data in rows. And data frame libraries like pandas just sometimes end up breaking and not being able to work at all, or being unreasonably slow, so it becomes frustrating for people to use. So like I mentioned, Apache Arrow is a columnar format. And so instead of storing your data in rows, it will store that data in columns instead, and that becomes more efficient for doing data analytics work, like calling different operations with pandas. So hopefully that helps you understand a little bit. That's just a small part of why Arrow is helpful for people working with tabular data. And now that you kind of have that background of why this project is helpful, I'm going to sort of tell you like the steps that I took to be able to practically make my first contribution to the project. So there are three key parts of making a successful contribution when you're working on an open source project. The first part is finding an issue that is relevant, that the maintainers actually feel is a good issue for you to work on, and that you have the skill set to be able to work on as well. The second thing is setting up your developer environment. And the third is actually effectively being able to solve the issue that you pick. So in this first part, finding an issue with the project is something that some people have a gift of, and some people are more talented or find issues with projects easily as compared to others. And actually, a big part of what drives many people to contribute to open source is the fact that they found an issue or something wrong with a project. And it's important to keep in mind that while it's great, actually, and you want to be able to identify issues with the project that you can improve on and help to fix, how you communicate to the maintainers of that project or the people in the community is really important as well. So for example, some people might feel really frustrated when they found a bug in their code, like of the packages they're using, or they might feel angry that something they've pointed out to a maintainer isn't being addressed immediately. And sometimes the response of those people is to act really harshly and interact with the maintainers in a really sort of unkind way that isn't considerate of the people in the community. And this ends up being really unhelpful or frustrating to the maintainers of the project. And that will not help you to be able to get a PR merged or to be a part of the project itself. So in 2018, actually, which was my first PyCon US that I've ever attended, Brett Cannon, who is one of the core Python developers, gave a talk encouraging members of the Python community to intentionally think about how they communicate online when they're trying to contribute to open source projects. And the three things he encouraged people to do when communicating online were to, number one, assume that you are asking the maintainer for a favor. And I don't know if I like the tone of that. I feel like I'm not sure about the tone of that statement, but I kind of agree with the general gist of coming from a point where we're all sort of working together. The second one is to assume that your boss will read what you say. So try not to maybe swear at people or do bizarre things because you might get fired, maybe. And the third one, if you don't have a boss, because there are many people who work on open source that actually don't have bosses and so don't really care if their bosses read what they're contributing. And those people should assume that their family will read what they say. So I think this is really good advice to keep in mind. And I would actually add on to what Britt said and quote the Roman philosopher Seneca, who said the greatest remedy for anger is delay. So if you are angry and you have run into an issue in a Python project that you want to contribute to, I would encourage you to maybe go for a walk, go and drink some water, delay actually talking to the maintainers of the project until you are not angry anymore and can contribute something to the project in a better state of mind. So in my specific case, when I decided to start contributing to PyArrow, I didn't actually have a specific problem that I was trying to fix. I just decided I wanted to contribute to the project. And so I searched for issues that were related to Python and felt like they fit into my specific skill set. And usually most projects that are open source will have a list of issues that they'd like to be addressed by the community that you can actually search through, and you can see if you're able to address one of those issues. Now, PyArrow uses Jira for its issue lists, and I am personally not a fan of Jira. So maybe there are many other, I know Jira's the worst. And there are many other projects that don't use Jira that use GitHub instead, and you can find a list of issues that they would like you to work on. So for example, this is actually the first issue that I ended up working on when I chose to get started. And there are a couple of things to note about this issue in terms of why I picked it. And the first thing is that it is a Python issue, so it has the label Python there. The second thing is that it's a good first issue. So that's a label that oftentimes, if you're contributing for the first time, you want to look out for that label. And even on GitHub, that label will probably be present. And even though it says closed there, I took a screenshot of this after the fact, after I had actually worked on this issue. And usually it should say open to signal that the issue is available for you to work on. So after reading through the description and realizing that, OK, I think I can work on this issue, I went ahead and I wrote a comment in the Jira ticket. And I talked to the maintainers, and they said, sure, you can work on this. And they actually assigned me to the issue there. And so that's something you hopefully want to be able to do. But even if someone doesn't assign you, you can still work on the issue. Now, the second thing you want to be able to do is you want to set up your developer environment. And for me, I think this is actually tends to be the most complicated part of the process, for me at least. And it is really good to be able to set up your developer environment, even if you don't feel confident about the solution you're working on, or if you don't feel confident about how you're going to solve something. And the reason for this is that when you have the developer environment set up, you can actually start to experiment with the different functions, and you can try out the code. And I find that as I'm experimenting with the function itself, that's when I start to have ideas about how to fix a specific issue. So Apache Arrow has their repo, and the code is available on GitHub. So you can, the first step in setting up your developer environment is going to be to fork and clone the GitHub repository. So you can just type in whatever projects you're working on in the GitHub search bar and grab if you go to the code button there, it will have like a link to how you can be able to clone that locally. So all of the commands that I use to clone this GitHub repository, the Apache Arrow GitHub repository, are on the screen there. And if you actually want to go through them and actually follow along with this talk, I wrote a blog post that I will share the link to at the end of this talk, where you can grab the code directly from the blog post. The second thing you want to do after cloning your repository is to run Arrow on your local machine. And to be able to run Arrow on your local machine, you need to build two libraries. The first library is the C++ library, and then the second one is the Python library. And again, this, for me, tends to be the trickiest part of starting up when you are now working on a new project, is just building the libraries. And one of the technologies that we use there is CMake. And I don't know if people are fans of CMake. I'm not sure how good it makes things. But sometimes it's good, sometimes it makes things complicated. But CMake is one of the ones that you use there. And something that's important to remember as well about why you want to build the C++ implementation of Arrow before building the Python implementation is that actually the Apache Arrow framework has a bunch of different people contributing to it, and different languages kind of have different strengths in what they do well and what they don't. And even though we had a fantastic talk today about speeding up Python, Python is still not very fast. And usually when you are wanting to speed up your code or make your code more efficient, you want to be using C or C++. And so the base implementation of Apache Arrow is written in C++, and you want to build that out. And then the second library that you're going to build is the PyArrow library, and that will just sit on top of the C++ implementation of Apache Arrow. And they're just Python bindings that bind those two libraries together. And you can take a look at all of this code on Apache Arrow's docs website. The docs are really good, I would say, so you can just go ahead and read those as well. Now, the third and final part of this talk is about solving the issue you just got started. If you got to this point of building all of the libraries and setting up your dev environment, you're actually about 70% of the way there when you first get started, I think. And it might not feel really intuitive, but when you're just getting started with working on an open source project, you're probably going to spend most of your time working on setting up your dev environment. And maybe 20 to 30% of your time is going to be actually spent solving the issue, especially when you get started. And that's something you should prepare for. I felt very frustrated when I got started, and this was something that happened. So yeah, just know that if you correctly set up your environment and things go well, and you set up a virtual Python environment, which along the way in that code snippets that I shared, you should be able to do that. Then after you've done the developer setup, then you're also, after you set up your developer environment, then you're also going to be able to do, solve issues much easier and more productively in the future, because you can just load up that environment again. So let's remind ourselves of what the issue looks like. This is the issue that I was working on. And as I am trying to solve an issue, my first goal is to understand how the function works that I am going to be working on. And so to do this, to help me understand how the function works, usually I'll open up a Jupyter notebook, which is where I usually feel comfortable in, or an IPython terminal. And then after that, I'm going to go on GitHub, and I'm going to look for this specific function. And I really like GitHub 1S, this thing that you can do when you go on GitHub, to be able to just to be able to see the function a bit more clearly. I use VS Code locally, and I prefer to use that in the browser other than like the GitHub interface that they give us. So you can just put a 1S after GitHub, and it should like change it into this format. And I'll just read through the function, understand what it's saying and what the changes are. And once I understand it, maybe read through the tests and also go ahead and sort of experiment with those locally. And then if I run into some errors, or I run into some things that I'm really not being able to figure out, the next thing that I'll do as a last resort maybe is to go back to the issue and comment on it, and talk to the maintainers and see if there's any advice they can give me about how to solve any issues that I'm running into. And then another step that we have that's really close to being done is to test and lint our code. One way that you can test your code is to use PyTest. A lot of open source projects use PyTest to be able to test your code. You want to make sure that once you've made those changes to the code, all your tests are still passing. And so that is the code that I ran to be able to do that. And then the second thing you want to do is you want to lint that code. I actually agree with Michael in terms of black being my personal favorite linter, but Apache Arrow uses archery. So being able to read in the documentation about what formatter the project prefers, and then using that format to be able to, before you push your PR to GitHub. And then the final step on your end of things is to actually make your pull request. And so a pull request is basically just you sharing the code that you've altered and sharing it with the maintainers of the project, so they're able to view your code and see specifically what you did to change it and if the changes gel well with the project. And so usually, these are the commands that I ran, and then I pushed my code to GitHub, and this was the PR that I ultimately submitted. And some things to note as well is that when you push your code to GitHub, people will usually review it, and people will usually tell you to fix things or tell you you're wrong. And I think at first, when people started doing that, I felt really bad, or I felt really insecure about my code. And that's something you have to get used to, that people will consistently be reviewing, and that's a good thing, actually, because it makes the project secure. And so you'll probably have some conversation back and forth with the maintainers of the project to be able to make sure that your code is ready to be merged into the project. So that's actually it for my talk in terms of how I ultimately ended up making my first PR to Apache Arrow. Like I mentioned, I made a blog post about this. It's available at marlenemanghami.com if you want to read that blog post. And if you want to speak to me afterwards about any questions you have, either about Apache Arrow or about how to contribute in general to any open source project, because hopefully these steps should translate to any open source project that you're wanting to contribute to, you can reach out to me. I'm marlene@voltrondata.com on my email. I'm Marlene_ZW on Twitter, and you can find me on LinkedIn as well. So thank you. Oh.
Thank you, Marlene. That was a wonderful talk, and making open source contributions was how I got my first job as a developer. It was through my open source contributions, so it's a wonderful thing to do. Do we have any questions? No, well, in which case, let's thank Marlene once again. Thank you.